Deep dive, sockets in adaptive autosar. 1. What are sockets? A socket is an endpoint for communication between two applications, processes, either on the same ECU, inter-process communication, or across different ECUs via Ethernet IP. Sockets implement the transport and network layers TCP/UDP IP of the OSI model and are standardized by POSIX. Role of sockets in adaptive autosar. In adaptive autosar, sockets are the underlying communication mechanism for all service-oriented communication SOA done via ERA-COM. Summary, open quote, adaptive autosar applications do not directly use raw sockets. They use ERA-COM APIs, which internally rely on POSIX sockets to implement some IP or DDS bindings. Close quote, thus, you can see the code in our conversation history. Number 3. Socket types. Used adaptive autosar supports both TCP and UDP sockets through POSIX APIs. Type, usage, example. Autosar use, TCP, SOC stream, reliable, connection-oriented, some IP RPC methods, DUIP diagnostics. UDP SOC DGRAM, unreliable, connectionless, some IP events, multicast, fast data streams, raw sockets, direct Ethernet access, special use cases, PTP time sync, diagnostic discovery. 4. Layers of communication. Adaptive stack. Here's how socket communication fits into the adaptive autosar architecture. You can see the code in our conversation history. 5. How communication happens via sockets. Step 1. Service offering. A provider-server application calls offer service via ERA-COM. Internally, the SOM IP binding creates a TCP or UDP socket using socket AF-INET SOC-stream/SOC DGRAM0. Binds it to a service ID and port number using bind and listen. Announces it using some IP service discovery, SD multicast messages. Step 2. Service discovery. The consumer calls find service via ERA-COM. It listens on a multicast UDP socket, e.g. 224.224.245.3049 for some IP SD messages. When a matching service is found, it connects to the server's socket. Step 3. Communication. Depending on the binding, TCP socket for method calls, reliable point-to-point, UDP socket for events, notifications, broadcast, multicast. Step 4. Data exchange. Data is serialized into some IP packets encapsulated in TCP/UDP frames. Sent via, you can see the code in our conversation history. Received data is deserialized by the some IP binding and delivered to the ERA-COM proxy skeleton. Now, number 6. Example socket code, POSIX layer. Although ERA-COM hides these details, under the hood, it's doing something like this. Server side, you can see the code in our conversation history. Client side, you can see the code in our conversation history. In adaptive autosar, these steps are abstracted by ERA-COM. 7. Some IP over sockets. Some IP, scalable service-oriented middleware over IP, defines how automotive ECUs exchange messages over Ethernet. It uses UDP sockets, events, multicast, TCP sockets, method calls, responses, some IPSD, service discovery, multicast UDP on port 30490. Each message has a header. You can see the code in our conversation history. So, sockets enable dynamic runtime binding. The client connects to whichever ECU offers the service. Now 8. Socket configuration in adaptive autosar. Socket configuration is typically described in network binding section of the manifest, JSON or RXML. Example, you can see the code in our conversation history. These parameters guide the ERA-COM binding layer in setting up and managing sockets. 9. Security on sockets, IAM TLS. IAM policies restrict which app can open network sockets. Secure communication uses TLS over TCP sockets for encryption and authentication. Certificates stored in ERA Cryptos ERA IAM key store. Example, secure DDoS IP. Secure some IP TLS. 10. Testing and diagnostics of sockets. During integration or HIL, Wireshark is used to analyze some IP or DoS IP socket packets. Verify. Service offers offer service, subscription and multicast reception, correct TCP/UDP port usage, reconnection and timeout behavior. Diagnostics also use TCP sockets, port 13400. Number 11, fault handling and PHM. If socket communication fails, broken pipe, connection reset, ERA-COM detects this via POSIX return codes, econ reset. EMPHM can trigger reconnect, service reoffer, application restart. Hammer summary table layer technology example. Usage, application, ERA-COM API, find service, offer service. Middleware, some IP DDS, serialization, discovery. transport, POSIX sockets, TCP, UDP, connection data exchange, network, IP Ethernet, physical data transmission, security, TLS-IM, encryption, access control. In short, open quote, in adaptive autosar, POSIX sockets are the transport backbone for Ethernet-based communication. They are managed by ARACOM, which uses protocols like SUM-IP or DDS to provide dynamic, service-oriented, secure data exchange between adaptive applications.